A new lesson, a new topic, right? Inequalities. So not a topic under numbers, the main topic, inequalities. Okay. Okay, so when we consider our syllabus, like in the combined math syllabus, especially at the first phase where we discuss the syllabus, there are few topics like that won't be directly, you won't be getting a direct question from that areas for your A levels. Okay. For example, if we consider like this inequalities, if we consider inequalities and then these recurring decimals, and there are a few more lessons to become partial fractions and logarithms, and those lessons you don't get a direct question for your A levels. For example, in the inequalities that we are yet to discuss, then partial fractions, recurring decimals, logarithms, you won't get a direct question. But out of those lessons, there are some lessons. In those lessons, like it will be important to another lesson. For example, if this inequality, you don't get a direct question from inequality. That is okay. That is true. You don't get a direct question. But the knowledge of inequality is required in lessons like quadratic equations, trigonometry, differentiation. You need the knowledge of inequality. So that is important. And the next lesson that we'll be discussing is partial fractions. So partial fractions, even though you don't get a direct question, when you're doing this series question, when you're doing this integration question, you need the knowledge of partial fractions. Meanwhile, there are some lessons, I don't know why those lessons exist in the syllabus. For example, the lesson we just completed, these recurring decimals, and then this area recurring decimals, and then another unit called logarithms. So those two areas won't be tested even in A levels, and even the knowledge of those two areas won't be impacted to another lesson. ඒ කියන්නේ ඒ පාඩම් වල knowledge එක ඔයාට වෙන lesson එකකට ඕනෙත් නැහැ. A levels වලට ඒකෙම silence. A levels වලට ඒකෙන් ප්‍රශ්නයක් එන්නෙත් නැහැ. එහෙම units තියෙනවා. Syllabus එකේ we have two of those units, three of those units. One is functions, function you can't say that you don't want it. But logarithms and recurring decimals, you won't get a question for A levels. But why do we do those questions? One thing, because in the A level syllabus you have those lessons. And the other one, in your school term test, especially in the first term test or the second term test, you will get questions from these recurring decimals and logarithms. Okay, so inequality is a lesson that you won't get a direct question for A levels. But when you are talking about some other lessons, you want the knowledge of inequalities. Okay, first thing, before talking about inequality, we need to again realize like what is a equality. Let's remind what is a equality. So if a mathematical expression is connected with an equal mark, simply when a mathematical equation is connected with an equal mark, we say that is a equality or equation. So this is what we call as the opposite of inequality, equality or a equation. So same thing. So according to this one, if a mathematical operation is, expression is connected with an equal mark, we call it as equality. No? So if we talk about the opposite of this one, an equality means this is equal to this. So inequality means the opposite, means that this is not equal to this. No. So if I consider inequality, that means not equal. But I know when I give you this word inequality, this is not the symbol that comes to your mind. So this is not the symbol. The symbol comes to your mind, it's either greater than 7 Or like you are getting the symbol less than 7. So this is what comes to your mind. When I'm talking about inequalities, you are talking about greater than, less than. The reason why we call this inequality, now look at this. Here, x is equal to 3. And if I write inequality, x is greater than 3, this says that you can't say exactly what is the value of x. You can't exactly say the value of x, but you can say that x is greater than 3. So the inequality is a comparison. In an inequality, we compare the magnitudes. You can't properly say, okay, x is equal to this one. But what can you say? The magnitude of x is greater than 3. So what do we consider as an inequality? A mathematical expression that is connected with an inequality mark. So what is an inequality mark? Greater than or less than mark. So this is an inequality mark greater than or less than. We call it as inequality. So always keep in mind, inequality won't give you an exact value. An inequality gives you a comparison about this magnitude. The size of this one is greater than 3. Clear? So that is an inequality. Okay, first write in this way. Write in this way. When a mathematical expression when a mathematical expression consists of a consists of a equal sign consists of equal sign, it is termed to be it is termed to be termed T-E-R-M-E-D termed to be, write in a black pen, an equality. It is termed to be an equality. Okay, next slide. When a mathematical expression when a mathematical expression is connected with a inequality mark or sign, is connected with a inequality sign within brackets, put this one. When a mathematical expression is connected with an inequality sign within brackets, put this one, greater than or less than, it is considered to be and in a red pen, inequality. It is considered to be, write using a red pen, an inequality. It is considered to be an inequality. Okay, then write these two examples. X equals 3 is the equality, or what we call as equation, and x is greater than 3, it's the inequality. So x is greater than 3 is the inequality. Okay, name it equality and inequality. So after that, write this. It is clear an inequality is a comparison. It is clear an inequality is a comparison of magnitudes. Is a comparison of magnitudes. Is a comparison of magnitudes. Okay, write it this way. Topic. Write the topic. Denoting areas shaded in a number line. Denoting areas shaded in a number line. Okay, so this is the important part. This one will be even the knowledge of this one you require in future lessons too. So we have a number line in this way. We have in a number line. And number line, the shaded area, if this is 2, the shaded area is in this way. So this is the shaded area. So how can I write this shaded area? There should be a name. No? So here, the shaded area of this number line is this area. Now I'm explaining like how we can write this. So this area we are writing using a variable. So mostly the variable is x. So you can write this x is greater than 2. So there are two notations. The first notation is an inequality notation. How you can write this? The first notation is a inequality notation. The next one I'll explain later. That is the set notation. How you can express this answer. So it is that is clear. And then the other one you know, if you can remember. If this one is colored, or if this one is shaded, then we consider the equal mark even. So what is this region? It's x is greater or equal to 2. X is greater or equal to 2. Okay. X is greater or equal to 2. And if you mark something like these inequality, small things that you know, but the main thing is the set notation. If I consider -1, so even here it's not included. How you can write it? Using x. X is less than -1. Okay, write in this way. A shaded area on a number line. A shaded area on a number line can be denoted in two main ways. Can be denoted in two main ways. Under that, number one, inequality notation. Number one, inequality notation. Number two, set notation. Number one, inequality notation. Number two, set notation. Okay, let's discuss the set notation in a while. Okay, now draw these number lines and write the inequality, and I'll put 4 more. Write the final answers. Write the final answers. Silence, 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 just silence. Do it alone, small thing, put it in. Don't make me repeat this, remain silence every time. Just do your work alone, that's all. Okay, so you can write these inequalities, these ones. Okay, come to this. So this one, it's x is greater than 2, but it is less than 5. X is greater than 2, but is less than 5. Here, since we have shaded these numbers, x is greater or equal to 2, but less or equal to 5. Okay. So in this one, when you come to here, it's you can see x is greater or equal to -1, less than 2, there's no inequality here. And if you write this one, it's x greater or equal to 4. No? So when you write this inequality, it's x greater or equal to 4. But there is something that we have to use here. Now let's say, so what are these areas? The areas that x can exist. So here we say x can be here. X is here, the areas that x can exist. So now it is clear, like when you have two areas, x can't be in both the areas. X will be in one of these two areas. Because at a given time, for example, let's say, now at school you are a prefect and you are in another society. So when one of your friend comes to your classroom to find you, you are not in the classroom at all. So then like the other classmates will be answering, he is not in the class. He is most probably he is in the prefix room. What is the preposition that you will be using? He, let's say he's in the music circle. So he was saying, okay, he is in the prefix room, blank music room. So what is the word that you are using? O. So you use this word O when X is in one of these two areas. So what is the word that you have to use? X can be either in this area or, so when we have two areas, it's O. It's not and, not and, because if it is and, that means X is in both areas. So X can't be in both areas. It's only one area. Okay, then this one, X is less than minus 3, O a greater or equal to 2 but less or equal to 3. And this one, x is less than minus 2 or x is greater or equal to 4. And this one, x is greater than minus 7 equal less than minus 1 or it's greater than 2 but it is less than or equal to 5. So write this properly. Clear? So you can write this inequality notation easily using this O when we are having two or more areas shaded. Okay. Now the next one is writing the set notation. Okay, next one is set notation. Okay, now listen. Proper listen, this is important. Even in other lessons, functions wage lessons a lot, you need this knowledge. Okay, now look at this. So here, I told you we are writing this using a set. So here I'm writing x is element. I'm writing x is element. So how can you write it? So what is this set? There is a way that we denote this set. So I'll give it separately. I'll put a topic and write it. But for the explanation, I'm just mentioning. How can we write this set? This is the set of all real numbers between 2 and 3. The method in 2 and 3 between all real numbers. So what is the numbers here? All the real numbers between 2 and 3. So here, how can we denote it? It's in this way. 2 comma 5 and we use these brackets 2 comma 5. So the meaning of this one is every real number in between 2 and 5, sorry. So this means every real number between 2 and 3 when you use this. Clear? So that is the set notation. So when I look at this one, okay, then you are going to write clear x is a element of this set. So I told you this set is 2 and 5. This set is 2 and 5. But now there's a small problem, no? What is the problem? Here, there's no equality. I have used the same notation. But even in here, when there's the equality, I have used the same notation. No? So there's a problem. So what is the problem here? Here, there's no any equal, but still I'm using this notation. There is a equality, but still I'm using the same notation. So for that one, there's a remedy in maths. If these two boundaries are included, which means if 2 and 5 are included, if there's the equal mark, we use square brackets. We use square brackets. So when it is a square bracket, that means this corner two terms are even included, including 2 and 5. So this is every real number between 2 and 5. But excluding 2 and 5, this is every real number between 2 and 5, including 2 and 5. Clear? Understand? Okay, hands up if you understood these two. Okay. Then when we are talking about, okay, now let's say, now we are talking about this one. I'm just writing additional one, this set. This one is 1 and this is 3. And I need you to write the set notation of this one. So tell me, how can you write this? X is element of, so how can you write it? It's 1 and 3, no? But 1 is not included, 3 is included. So when it is not included, we use the normal bracket. You don't say it curve bracket, normal bracket. Bracket kill again, bracket Q again. Other have terms, square brackets, curly brackets, bracket. Okay. So here we have in this bracket, but here 3 is included, no? So what is the bracket we should use? Square. I know this is a bit unusual. Because you haven't written these kinds of brackets. You haven't written these kind of brackets in Sinhala, English or any other subject. Sinhalin මෙහෙම ඇරියොත් මෙහෙම වහන්න ඕනේ. Even in English, when you put this one, you have to put this one. But in maths, this is a notation. When we put this one is not included. When it is a square one, it is included. Clear? Okay, now you need to tell me this one. Clear? Okay, now come to this one. This number line. Okay, now listen. So here in this number line, when you continue, now this goes no. You can't see here, there's no any boundary. It continues to this side. So tell me, when you go to this, continuously go to this side, what do you find? Like, whom do you meet? Where do we say that number line ends? It's infinity, no? It's at infinity. Which means, when you go to this side, what is the number that you meet? It's minus infinity or negative infinity. Clear? So when you continue to go in the straight line towards this line, we said that the straight line finishes at, the number line finishes at infinity, but it doesn't finish. We say we get infinity. Okay, now the interesting part. I'm asking you to write the set notation. You are writing the set notation. X is element of, what is the bracket? A normal bracket, what we say, the bracket 2, and then we have infinity. No? I'll give you 10 or 20 seconds, and then I'll be asking the answer. I need you to think what is the bracket that we will be using here. Okay. I'll be asking it later in 20 seconds. Think and tell me what is the bracket that you will be using here. I'll be asking, wait. Think, I'll give you 20 seconds. What is the bracket that you will be using here? Okay. Okay, now I need everyone to raise their hands for any of the option. Okay, hands up if you are telling that we will be using this normal bracket here, like a normal bracket here we will be using. But I need everyone to raise their hand for anyone, any option. Okay, few are there. Okay, hands up who are telling that this is what we use is the square bracket. Others are using bracket, others? Again. Mago Munari Sadminika Munari chance. This is not a question between life and death. It's a small one. Abhi tanne someone Haryana පුළුවන් අර දැන් අර ඊයර ලොටරි එක ගත්ත මිනිස්සයා නිකන් එහෙම හිතුවද කියන්නකෝ the largest ever lottery winner in Sri Lanka. Like yesterday night it was the largest ever prize money in a lottery ticket in Sri Lanka. Like he won. පොඩි ගානක් නෙමෙයි, he won like 47 crores කෝටි 47ක්. ලක්ෂ 4700ක්. Okay, that is the largest ever prize money because why it is the largest one? It's first there is a letter, then there are four numbers, from 1 to 99. There are four numbers 1 to 99, not 1 to 10, okay, 1 to 99. And then there is a super number between 1 to 26. 1 to 26, oh, I can't, yeah, 1 to 26. So I don't know whether super number is here or here. Like we have a letter and we have the super number which is out of 1 to 26. And then we have these four numbers. And like these days we are doing a lesson for 2025 called permutations and combinations. So using that lesson, we can find how many patterns of this, like how many number of lottery tickets are there if we print this. Like you can put A and for example A, and this is 1. If you take the super number is 1, and then you can put 1, 2, 3, 4, not only 1, 2, 3, 4. How many numbers? Like you can put any number between 1 to 99 here. So chance of matching all these 6 is 1 out of a billion. ලොට්‍රි ටිකට් බිලියන් එක බිලියනයක් ගහන්න නෑ. එච්චර පින් කරන්නෙත් නෑ. මේ ඔක්කොම ටික තියෙන මේ ලොට්‍රි ටිකට් එකක් ගැහුවොත් අනිවාර්යයෙන්ම කාට හරි වෙන බිලියන් ගහන්න නෑ. So අර chance එක මේක හම්බෙන්නේ it's 1 out of a billion. Billion 1 and 9 zeros. So that is a probability that happened yesterday night. Something that having a probability of 1 out of 9, 1 like 1 out of a billion. Just imagine. So that is how luck works. We don't. And this question is not something a lottery ticket. But I'm just telling you, like when you are supposed to answer a question, just do it. Just do it. We don't know whether it might work or not. Even this may lottery card, antima lottery ka you can just go buy it and like there are instances in like in the history where when a person go to a lottery cage, like real history, not this much of amount. Like imagine, but in like not even in but in Sri Lanka, not even in Sri Lanka, in other countries, when you get a amount as gift, you have to pay taxes. Okay, you have to pay taxes, but in Sri Lanka, it's really less. For the Lakshapati, when you win 1 million, you don't get 1 million. You are getting 8,070,000. Sorry, you are winning 1 million, you are getting 870,000. When you, that means 130,000 you have to pay for taxes. But that is really less. Because I saw this article in tennis, like recently there was a tennis tournament, like French Open. And there was a Spanish tennis player, his name is Carlos Alcaraz, and he's the one who won it. And he got 29.8 something million dollars, 29.8 million dollars as prize money, but he will only receive 14 point something. Because in Spain, the taxes are more than even 50%. So even in this lottery ticket, but in like, let's say he's getting 470 million. Okay, ලක්ෂ 4,700ක් හම්බ වෙනවා. ලක්ෂ 4,700ක්. Okay, so then even after paying taxes, he will still have more than 4,000 lakhs in his hand. So that is how luck works. We don't know. And like you saw that Airbus India accident, no? Like out of 242, just one person is just coming outside like a film. I mean, that is impossible. No? And he is telling like he has taken a call to his father who is in London to okay, now the plane is about to take off. Now like, he has taken a call to his father about like now the plane is about to take off. And again after 10 minutes he's taking a video call to his father and telling the plane got crashed. And previously video like they shown that he is walking along this air track. But yesterday there was a new video release, and we all have these fire trucks and then he's just walking and coming. So that is how luck works. We don't know. And there was another woman who got 10 minutes late to the airport and missed the plane. Imagine coming to the airport and then all the boarding process has been done. You won't be able to go to the plane. And we are worried, no, I ticket ගන්න ගියාම අරකේ full refund එක හම්බෙන්නේ නැහැ. We are thinking about the money. And then she get the news that the plane has crashed. So that is how luck works. We don't know. In some again, put it like even this is not a good example to tell that. But when you have a chance, just take it. මේක අතුස්සන්න ගම බයයි ලැජ්ජයි වරදිත් දන්නේ. No one is looking at you. Only I'm looking at you. Whether you gave the correct answer or not. Okay, so when I ask something, just answer it. I need answers. Okay, just no one is looking at you. හරිද? කවුරුත් බලන් ඉන්නේ නැහැ. මම විතරයි බලන්නේ. මම දැක්ක තවුලන්නේ නෝන්ඩිය වැරදි කියලා. I don't assume in that way නේ. Okay, now tell me. Okay, back to the question. ඔක්කොම ඉවරයි. ආබස් ඉවරයි, ලෝරි ඉවරයි. Now listen this. Now tell me, if you are telling the first question, okay, hands up if you are telling that we are using a normal bracket here. In this one, we are bounded it by a normal bracket. Hands up. Okay, silence. Okay. Hands up if you are telling that we are using a square bracket. Okay, the logic is simple. What is the logic? If you are telling that it is a square, a normal bracket, you are telling me that x is not equal to infinity. It's not equal. But if you are using a square bracket, you are telling that means x is equal to infinity. So that is the logic behind that. No? If a square bracket, you are telling me, like, because in this case, when it is a normal bracket, x is not equal to 5. Not equal to 5. But in this case, x is equal to 5. Okay, now, tell me, is infinity a number? Is infinity a number? No, infinity is not a number. It's a mathematical concept we use to a huge value. So you can't say that infinity is exactly this. Let's say you assume in 1 trillion means 1 and 12 zeros is infinity. So 1 trillion is infinity. So it's a huge value, no? So if you are telling me 1 trillion is infinity, then what can you say about 2 trillion? 1 trillion is huge. 2 trillion is 2 times huge than that. Is it 2 infinity? No, you can't say that. So no, keep in mind, infinity is not a number. It's a concept. It's a concept we use to a huge value. So x or any number can't be equal to infinity. So when we have infinity, we are using a normal bracket. We don't use square brackets with infinity because we don't get this instant where x is equal to infinity. This is wrong in math silence. In maths, you don't get this. You don't write this. No, x is equal. No, that's wrong. So always keep in mind when infinity is we are talking about infinity, we should use a normal bracket. So here, x is element of square bracket 2, silence. X is an element of square bracket 2 and it goes to infinity. So when we are writing infinity, it's always, we call, I'll give a name, we always use the normal bracket. Okay, so in this case, I told you the number line, if it continues to this side, you get the minus infinity. So when you write this, it's x is an element of minus infinity, minus 1 not included. Clear? Okay. So let's write in this way, put a small topic, set notation. Set notation. Set notation. Okay, so now we know so what is the set notation. So if I write, I'm writing 4 set notations, 2, 4, then square bracket 2 and 4. This is the normal bracket and the square bracket, and the last one is 2 and 4 in this curly bracket. Okay, 4 notations. So here, what is this? Real numbers between 1 and 2, here 2 and 4, sorry, real numbers or all real numbers between 2 and 4, but we have excluded, we have excluding 2 and 4. In between 2 and 4, but excluding 2 and 4. So this one, same one, all real numbers between 2 and 4. Okay, here we have included it, including 2 and 4. In this case, you know same thing, but 2 has been excluded, 4 is included. So this set is all real numbers between 2 and 3, sorry, 2 and 4. Write it properly. We have excluded 2. Excluding 2, including 4. We have included 4 and we have excluded 2. Clear? Okay, last one. We have used the square brackets 2 and 4. So out of these 4, before today, this is the only bracket you knew in maths, in sets. This is the only bracket you knew in maths. So what does curly bracket 2 and 4 says? What does this say? Only 2 and 4. Because that is what we had for O levels. No, because inside curly brackets, if you write 1, comma 2, comma 3, that means there are three elements 1, 2, and 3. Okay. So here it's only the element, not a range or not a this entire set, only 2 and 4. So curly brackets. So that is what you knew like previously, only 2 and 4 elements. Only the two elements, 2 and 4. Okay. And there's a name that we give for this one. When we use this normal bracket, we say it's an open interval because like the corners are open. We say it as an open interval, and when we use square brackets, we say it's a closed interval because it has been locked from those values. So this bracket, open intervals, close intervals. This is open, but this is close. Clear? So you have two specific names: open intervals, interval, and close interval. Okay. The topic is set notation. Write in this way. And on a number line, an area shaded on a number line can be denoted using sets, can be denoted using sets. Just in the sentence, using sets. Okay. For that purpose, the following set notation is required. For that purpose, the following set notation is required. Is required. Okay. Okay, then write these four and write it properly and mention this open interval and close interval story. Mention this open interval and this close interval story. Okay, then write the set notation of under every number line. So previously you can just write the answer there itself. You don't have to draw this again. Below the same number line, write the set notation even. So under the same set of number lines, write the set notation. Okay, so write the missing set notations. Here it's x is element, it's starting from minus infinity and coming up to 3. 3 is included, so it's a square bracket. So these two, I wrote this one. So when you're writing this one, here x is element of minus 1 is included, 2 is not included, and then 4 is included, and it goes up to infinity. With infinity, we are using a open interval. Okay, now when you come to sets, here if you write x is element of this one or this one, it's mathematically correct. I can't say it's wrong. If you write O here, that is correct. But the thing here, normally we don't use words with sets. We don't use this O and with sets. So you have to use symbols. So what is the symbol that is equivalent for this O? It's the union of the two sets. So what is the symbol that is equivalent to O? That is the union, not the intersection. Okay, not the intersection. So when you are writing sets, don't use this word O, use the union. Union, you know, the union of sets. This one, x is a element of minus infinity, minus 3. And now you know it's a union, a square bracket 2 and 3 is included. Okay. This one, x is a element of minus infinity coming up to minus 2, union starting from 4 going up to infinity. Starting from 4 going up to infinity. Okay, then this one, x is element of minus 7 square brackets minus 7 minus 1 normal brackets 2 and going up to 5. Clear? So it's minus 7 minus 1 the union, and it's starting from 2 and going up to 5. Going up to 5. Okay, so with any of these brackets where you have infinity, any of these brackets, I own infinity තියෙන එක තැනක put a red arrow, and write this like any place where we have infinity, put a red arrow and write this with infinity, with infinity we have to use an open interval. With infinity we have to use an open interval. With infinity we have to use an open interval. Okay, then write the topic rules of inequalities. Write the topic rules of inequality. Okay, rules of inequalities. Okay, so let's start with the basics. Things that you know. You're talking about the rules of inequality. When there's inequality, things we can do and we can't do. So first one is, when we have inequality, if A is greater than B, can we add the same number to the both sides of inequality? Inequality the same number can be added? Can or can't? Can we add the same number to both sides of the inequality? We can. No. You can add. No. In inequality, you can add the same number. So here, you can add the same number, add in C to both sides. You can add the same number. So it's plus C plus C. No harm. I'll take example. If you write a example, when you write an example, it's 4 is greater than 2 and I'm adding plus 1 to both sides. No harm. 5 is greater than 3, which is correct. Clear? So now when it comes to maths, like there are certain things that you know and certain things that you are not sure yet know. But what I want you to say that don't doubt about the things that you know. දැන් වෙලා තියෙන දන්න දේ ෂුවර් නෑ. පුළුවන්ද? You know, can you remember you did this for O levels? No. When there's inequality, we can add the same number. Don't doubt the thing that you properly know. හරියට දන්න දේ doubt කරන්න ඕනේ නෑ. Not sure now you can just have a, okay, I'm not sure whether it is correct or not, but if not, just if you're sure, that's sure, okay? Okay, right, first rule number one, write this. Write this. Any number can be added. Any number can be added. Any number can be added to both sides of the inequality. Any number can be added to both sides of an inequality. To both sides of an inequality. Okay, then write it if A equals B. Then you can add C to both sides. Okay, next one. Okay, now can you tell me whether you can subtract the same number from the both sides of an inequality? Can you subtract? Can or can't? Okay, so if you can do anything for addition, you can even do that for a subtraction, because subtraction and the addition is like the same mathematical operation. You know, when you have to subtract two numbers, 3 minus 2, you can write it as 3 plus minus 2. So a subtraction can be considered as the addition of a minus number. So if in maths, if anything is correct for addition, that is even correct for a subtraction. If anything is correct for addition, that is even correct for a subtraction. Clear? So there's no any mathematical concept or rule that is valid for addition, but that is not valid for a subtraction. Okay. So then both sides can be subtracted if A is greater than B. If A is greater than B, you can subtract the same value from both sides. It's A minus C is greater than B minus C. Okay. Write the second rule, rule number 2. Any number can be subtracted. Any number can be subtracted from both sides of an inequality. Both sides of an inequality. Both sides of an inequality. Okay, then write this second one. Okay, third one. Now tell me, I'll be asking whether you can do it or can't do it. You have to raise your hand. Okay, hands up if you're telling me both sides of an inequality can be multiplied by the same number. Hands up if you're telling yes, you can multiply. Okay, hands up if you're telling no, you can't multiply. Okay, so you can multiply both sides of an inequality by the same number. But there is one thing that you need to, you have to consider. What is it? If you are multiplying by a positive number, that is okay. But if you are multiplying by a negative number, you have to change the sign. You can multiply. Admit you can multiply both sides of an inequality by the same number. There's no rule that you can only multiply by a positive number. No, you can. But there is one thing, when you multiply by a positive number, that's okay, the sign remain unchanged. But when you multiply by a negative number, make sure that you change the sign. Clear? You know this, so if we interpret this in this way, if A is greater than B, I'm considering that C is positive. C is positive. Okay, now when I multiply by C, there's no any sign change. There's no any sign change. A into C is greater than B into C. No change. So if you take a example, I'm writing 5 is greater than 3 and I'm multiplying both sides by 2, which gives me a correct inequality. 10 is greater than 6. Okay, 10 is greater than 6. But in the other hand, if it is negative, now it is clear. I told you when it is negative, you have to make sure that the sign changes. The sign changes when you multiply by C. When C is negative, previously it was greater than, now it becomes less than. Previously it was greater than, now it becomes less than. To take example, 5 is greater than 3. So when you multiply by minus 2, make sure you change the sign, because you know that minus 10 is not greater than minus 6. It's less than minus 6. Minus 10 is less than minus 6. Clear? Okay, things you know. Write rule number 3. Write in this way. Both sides of an inequality, both sides of an inequality, both sides of an inequality can be multiplied by the same number. Can be multiplied by the same number. By the same number. Next line. If multiplied by a, write in a black pen, positive, Only that one. If multiplied by a positive, then normal pen number, when multiplied by a positive number, the sign right in a red pen remains unchanged. The sign remains unchanged. The sign remains unchanged. The next line, if multiplied by, if multiplied by, if multiplied by a, write in a black pen, negative normal pen number, same one, same as the previous, write in a black pen, negative number, the sign, then a red pen changes. The sign changes. You have to make sure this change, then you can divide it. Sorry, you can multiply. Okay. When multiplied by a negative number, the sign changes. Okay, write this. So C is greater than 0 means it's positive. C is greater than 0 means it's positive. And C is less than 0 means it's negative. C is less than 0 means it's negative. Only this one, number 3. Yeah? Rule number 3. When multiplied by a positive one, the sign won't change. But when I multiply by a negative one, only number 3, yeah, don't write number 4. Okay, write number 4, rule number 4. Rule number 4. Both sides of an inequality, both sides of an inequality, both sides of an inequality can be divided by the same number. Can be divided by the same number. Can be divided by the same number. Okay, next line, same thing is happening, so I won't be giving it in the same way. I'll just mention the sign change rule is applied as in the previous way. Okay, same thing. Now when you divide by positive, no change, negative change, right? Next line. Even here, even in division, even in division, even in division, the sign change, the sign change applies, the sign change applies as in the previous manner. The sign change applies as in the previous manner. As in the previous manner. Okay, then just write this if A is greater than B. If C is greater than 0 is positive, then no sign change. Here there's a sign change. Okay. Now being honest, like these 4 rules, you knew these previously. No? For O levels even you didn't. It's negative. Okay. So even in O levels, so if you have written this as negative shape, for a positive shape, and it's negative. Okay. Okay, now tell me, like, being honest, like for O levels, you have done all these 4. No? By now, you know all these 4 rules. But when it comes to A levels, there are 3 additional rules that we should discuss. There are three additional rules related to inequalities that we should discuss. But there is a listen. No. Okay. But there is a problem here because in order to discuss those three rules, we need the knowledge of a concept called modulus in maths. Okay, so discuss the remaining three rules, we need the knowledge of a modulus function. So modulus function is a lesson that we will be doing in 5 weeks. So that is a lesson that we will be doing in the future. Without the knowledge of a modulus, we can't discuss the remaining three rules. Then you might ask me the question, okay sir, then we could have done modulus first and then start inequalities. But more than 50% of the modulus lesson runs through inequalities. So without inequalities, you can't do modulus. Without inequalities, you can't do modulus. But without modulus, you can do inequalities. Only we require the knowledge of modulus to explain this next three rules, set of rules. But all like you got a one paper, this inequality tute, we can do every question in that tute without the knowledge of modulus. But to explain the small part of inequalities, we need the knowledge of modulus. But that doesn't mean that I could have done modulus and come to inequalities, because to do modulus, you need the entire knowledge of inequalities. Okay, so that is the situation. So that's why I'm not doing it here. But I'll just simply explain what are the rules that we will be learning. And I'll ask you to keep space, because again, after doing modulus, we'll be coming here one day. So then we can complete the note. So what are the rules? One thing is when we have inequality in this way, what can you say about the reciprocal? What can you say about the reciprocal of both sides? 1 over A and 1 over B. So what can you say about the reciprocal? Then if I take an example that 3 is greater than 2. Okay, 3 is greater than 2. Accept. Okay, so 3 is greater than 2. I'm writing the reciprocal. What is the reciprocal? This side, what is the reciprocal of 3? 1. Reciprocal 1 over 3. What is the reciprocal of the right hand side? 1 over 2. Okay, now tell me, out of these two, what is the larger one? 1 over 3 again is 0.3, 1 over 2 again half. So what is large? So it's half. No? So what happened to the inequality? It changes. So now you might think, okay, if it is the reciprocal, inequality changes. If the denominator is increasing, this entire number is decreasing. If a denominator is increasing, the entire number is decreasing. So when A is greater than B, it is clear, you might think that it is change in the sign. But if I write something like 2 is greater than minus 3, now what happens? Tell me this side, what is the reciprocal of minus 3? 1 over minus 3, which is minus 1 over 3. You know. What is the reciprocal of 2 again? 1 over 2. Okay, now out of these, this is a positive and this is a negative. So this is greater. No? So here we thought, okay, if it is a reciprocal, the sign changes. But in this case, you can see the sign doesn't change. So to explain this properly, we need the knowledge of a modulus. And the next thing, if A is greater than B, what can you say about A squared and B squared? What can you say about A squared and B squared? Every time think from example. Think from example. Okay. I'm taking 4 is greater than 2. When you square 4, you get 16. When you square 2, you get 4. So it is clear 16 is greater than 4. Then you tend to think if A is greater than B, okay, then A squared is even greater than B squared. You get that feeling? But what if I compare 2 is greater than minus 2? And when I square this side, 2 squared, it's minus 3 squared. 2 squared is 4, minus 3 squared is 9. This is wrong, this is correct or wrong? It's wrong. So here you saw that there's no any change of the sign. But here, there is a change of the sign. So here it's wrong. No, this is not correct. So this is wrong. That means the inequality changes. So here we are getting these contradictory answers because we don't have the knowledge of a modulus. So that's why we are getting contradictory answers. Once it's correct, in the other way it's wrong. Once it is correct, but in the other side it's wrong. To explain about this, we need the knowledge of a modulus. Okay, now you don't have to think about this one. Don't get things complex. Let's keep things simple up to these four rules. But after doing modulus, I'll be again coming to here. Okay, but I'm mentioning it here. I could have easily skipped this and go. And later, after doing modulus, I can come back and tell you, okay, we skip this part, skip this part. But I don't want to do this because in case if you like, if this one is done in another class over at your school, then I get compared. Then you might think, like, for example, a school teacher like might do modulus even inside this and explain the rules. So that happens to make ඇතුළෙම modulus උත් කරනවා. කරලා මේක මේ rules තුන explain කරනවා. Then you are getting this feeling, okay, I didn't do that. So that's why I'm just mentioning it and going, but again I'll be coming here. Okay, put a red star mark and write in a normal pen. Put a red star mark and write in a normal pen. Try this to discuss about to discuss about to discuss about considering the reciprocal square comma square and square root, to consider the reciprocal comma square and square root of both sides of an inequality, both sides of an inequality, we require the knowledge of the modulus of a number. We require the knowledge of the modulus of a number. Okay, then if you have written this line at the top of your page, just keep that page, like keep one page as a space. But if you have written that line in the middle of the book, keep that remaining part and an additional page. Like if you have written this sentence which I just gave at the top of the book, keep one CR page. But if you are written in the middle of a page, just keep that half and then come to the other side. Keep that one, start from a new page. So being simple, like, yeah, I need at least one CR page or 1.5. So one is even okay, but if you have a half, make it 1.5. Okay. Okay, so write in this way. Silence. Write in this way. There are two types of silence. There are two types of inequality questions or problems. There are two types of inequality problems or questions. There are two types of inequality problems. Under that first one, solving an inequality. Solving an inequality. Number two, proving an inequality. Solving an inequality. Number two, proving an inequality. Proving an inequality. Okay, write the main topic, solving inequalities. Write the main topic, solving inequalities. Silence, the last part for today. Silence and pay attention. Try the main topic, solving inequalities. Okay. Okay, before talking about solving inequalities, if I ask you to solve an linear equality like this way, I'm asking you to solve this linear equality x plus 2 is equal to 7. So when I ask you to solve this, what do you normally do? You take the 2 to this side and you write the answer that x is equal to 5. There you write the answer that x is equal to 5. So here, what we have done, when we have to solve an linear equality, we simply subject that variable. We subject that. We subject x. So same thing will be applied in a linear, okay? Linear, you know what a linear, where we will only have x. So when you have a linear inequality, same drill, what you have to do, you have to subject this variable. You have to subject this x, so you get x is greater than 5. So same drill, when you are supposed to solve an inequality, which is a linear inequality, simply what you have to do, you have to subject the variable. We have to subject the unknown term. So here it is clear, when it is an equality, the answer is even an equality. When you simplify, when you solve an equality, the answer is even an equality. But here it is clear, when you solve an inequality, the final answer is even a, tell me, when you solve an inequality, so these are jack positions. Jack. Even though you are full focus, when you keep your hand, automatically you fall asleep. Okay. So here, when you solve an inequality, the final answer is an inequality. When you solve an equality, the final answer is even a equality. So every time when you solve an inequality, the answer comes in terms of an inequality. So here you can see the answer is a inequality. So I'm just mentioning about linear inequalities, how you can solve them. Simply we have to subject them. Okay, write it this way. Write it this way. To solve an red pen linear inequality, to solve a, write in a red pen, linear inequality, to solve a, in a red pen, linear inequality, normal pen, we have to subject the unknown term. We have to subject the unknown term. We have to subject the unknown term. Same line, the final answer we get, the final answer we get when we solve an inequality, the final answer we get when we solve an inequality is also an inequality. The final answer we get when we solve an inequality is also an inequality. Okay, then write these two first towards the both sides of the book, these two, and then I have put 2 questions. You can do that and complete the work. Complete the work. First write these two and show that this is a equality, but this is inequality. And then do those 2 questions. First write these two towards the both side of the book. And then solve these two. Okay, this one you can, I ask you to subject x, no? So when you subject x, it's 2x is greater than 8. You can divide both sides, which gives you x is greater than 4. So every time when you solve an inequality, the answer is an inequality. Okay, this one, take 3 to this side. It's 5 minus 3. So you get minus 6 is greater than 2. But you need to subject x to. So what can you do here? You can divide by minus 1. Or you can multiply. Both are okay. Kadanatan? You can divide by minus 1. So when you divide by minus 1, Make sure you do this properly, because when you divide or multiply by -1, what happens to the sign? It changes. So it changes. So here it is less than. So minus x divided by x is x. It's less than -2. So we get the final answer. X is less than -2. Hands up who got x is greater than 4 and x is less than -2. Okay. Just write the topic and keep this. Write the main topic and let's keep it. Solving non-linear inequalities. So that is the main topic. Solving non-linear inequalities. Solving non-linear inequalities. Okay, you can get ready to go. Okay, quickly. 1 minute. Anu? Okay, silence. 1 minute. Huh? Okay. So next week, Anna. Okay, so next week we will be finishing this lesson inequalities, and then week after, which is the 1st of July, we will be having a proper exam, not like what we did in basic mathematical concepts. That is like a 1 hour, 1.5 hour paper. So we are having maybe most probably a 2 hours or 2.5 hours paper, and the paper is with consisting of polynomials, recurring decimals, and inequalities. So I'll tell more details about the exam next week. But another additional thing, I told you at the end of every unit we do in the classroom, we are doing an additional online session to complete the past papers that we didn't complete at the class. Okay. So I'll be doing that for polynomials on Sunday, coming Sunday at 9 o'clock, 9 p.m. in the evening, because even though you have classes, you can go home and take a wash, and I'll be doing it through YouTube as a YouTube live. So what I want you to do is, before coming to that session, try to do the past paper questions that we haven't done of polynomials after 2011. But don't do 2022 and 23, because there's a differentiation part. You can't do that. Try to do the questions. I'll be discussing the questions that we haven't done in past papers, and even in the tute there was like 2 sets of questions that is not tested in A levels but for term test, and you might get these questions. I'll be doing some additional questions. So that one I'm doing, like I'm even asking the single medium students to join that session. So I'll be balancing the class, but I'll make sure that even though you join it, you will be like, you can like properly understand it, even though I'm like doing it in both languages. I'll make from my end, I'll make sure that every English medium student can properly understand it, because I'll be repeating every definition or every logic or every theory that I mentioned through the in the session, even in English. සිංහලෙන් කිව්වොත් එහෙම භාජකයේ මාත්‍රයට වඩා ශේෂයේ මාත්‍රය අඩු වෙන්න ඕනේ කියලා I'll tell it in English. You don't know what is භාජකය. භාජකය is divisor. The degree of the divisor is less than the degree of the remainder. So I'll make sure that I'll repeat that. So this Sunday, silence. Okay, this Sunday at 9 o'clock, I'll be doing that. Clear? Okay, we are done for today. You can go home safe.